Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. Right, today is day 26 of our ongoing series 60 out of 16 KCET mathematics. Right, what we have done so far, we have completed recently a chapter which was application of derivative. Right, we have taken 3 parts. Okay, in that we learned the concept, we also revised. Okay, we also did a session on PYQs. Okay, now coming up is the most important chapter, the highest weighted chapter for your entire KCET examination, which is integration. Okay, very important chapter. The entire calculus is important, but again the heart and soul of the chapter is what? Heart and soul of the unit is what? Integration, sir. Lot of students have difficulty in this. Lot of students enjoy this chapter as well. For example, I personally like this part of calculus. Integration I find the simplest. Okay, there are certain rules which is there, we have to follow that, stick to that, and can solve any question. Okay, so we are starting with our session 1, part 1 of integration. Okay, in this session we'll only talk about definition, what is integration, okay, how we approach it, and then we'll see some questions, very basics questions on the rules of different integration, and we'll see and we'll solve them in the session. So it'll be a very fundamental session, not advanced questions, very simple questions we'll take. Okay, we'll try to build our concept in the integration, the way we built in differentiation, the way we built in AOD. Same way in the first session we'll build our concept, our understanding of the chapter in the first session. So I hope all of you are very prepared. Right, beginning of a new chapter. Right, let's start with the session. Take your pen and paper out. If you need to have, one more thing, if you can keep the formula sheet for differentiation with you, it will be very helpful, because when I write the formulas for integration, you can relate from there. Okay, so if you can keep the formula sheet of differentiation, I also gave it with you. Okay, now let me start with the session. First coming up is what? We'll work on definition of the integration. So what we know, integration as the inverse process of differentiation. Okay, means for a function, okay, we should differentiate, okay, and we should get some result. Remember this. Means what was the differentiation process? We should take a function, bacha, f of x, differentiate this, and we get what? F dash of x, f dash of x. But if I do the inverse process, means if I integrate this, the symbol for integration is this. Okay, this is a symbol for integration. Okay, a weird looking elongated s. Okay, this will give me what? The function fx. One more thing, we'll see that later, there will be a constant c. We'll see why is that true, we'll see that later, but for now accept it. Integration of the f derivative of x will be what? Fxc. Okay, so again there are some certain rules. This is not complete definition, but for now just understand this statement. Integration is what? The inverse process of the differentiation. Okay, so before learning this, what is integration? If I ask you, what word should come for you when you hear this word integration? What comes to your mind? What should come to your mind when you hear the integration? Usually people will say differentiation, sir, or inverse of differentiation, sir. But the correct answer should be, a right answer in the answer in the right way should be sum. Whenever I hear the word integration, means sum of something, sum of few functions or collective value of something. Integration means what? Collection of something, when taken together. Okay, so first thing that comes to our mind is sum. It should be what? Sum, sir. Means integration is nothing but sum. Okay, let's erase this part. We'll see the inverse process later also. We'll see how this is working when I'm writing your formulas for different functions, but we'll see first this part. Integration means simply sum. Then sir, summation we used to do it like this, no? Write sigma. Okay, if I'm writing, let's say, for what? A natural number n, what is to write? Check here. 1 plus 2 plus 3 plus 4 plus so on till n. Then why we need integral, sir? Why we need integral? If you check carefully, what is this function, bacha? What is this? What type of data is this? Discrete data. Means individual values are there. 1 is separate than 2, 2 is different from 3. So there is a break in this entire series. Okay, what type of data is this? Discrete. It is what? Discrete. So because we are dealing with discrete type of data, okay, discrete function, then I can use what? Simply summation or sigma notation to get our result. But whenever this function becomes what, bacha? Continuous. It becomes what? Continuous. Or the data becomes continuous. Then the same operation, which is what? Collecting all of it together, that becomes what? The new terms comes there, which is integration, which is integration. So at that point of time we use integration. This much is clear. Why integration? Where we use integration. So again, integration is the sum of everything, okay, wherever we are talking about. Next, whenever we are dealing with continuous type of data or function. Okay, now this is of two types. This is of two types. Type 1 is definite integral, okay, or let's call the first type to be indefinite integral. Indefinite integral, whereas this is definite integral, okay. This is definite integral, okay. Means over here, this will not have a unique answer. Indefinite integral will not have a unique answer. So it is indefinite. No, it's not definite. Means it's not a fixed value. If I keep changing what? We'll see that. I wrote here something written as f of x plus c. If I keep changing my c value, okay, this will keep changing. This will keep changing. Means there are certain restriction. If you provide some restriction over indefinite integral, it will transform into definite integral. We'll see what is that restriction when we deal with definite integrals. For now, just have a look. Indefinite integral means what? It means, so whenever the integration has, no fixed value, okay, it has no single fixed value, so that's why the name is indefinite integral. So for today's session, for the first part, we'll learn what? We'll learn only indefinite. So what we do is, we learn all the types of integration, all the approach with the help of indefinite, then one modification we do in the indefinite integral and we reach to definite, okay. So all right, these are two types of integration. Okay, sir. All right. This I understand, sir. Let me read this statement. What is given there? What's given there? Let fx be a function of x if there is a function gx, okay, such that differentiation of gx is fx. Means if I differentiate, what is this written here? Differentiate gx not equal to differentiate gx, I reach fx. Then gx is called as integral of fx with respect to x. So variable is very important. No, x is the variable of integration, okay, and this is what? This is my original function gx. Then I can call this as gx to be integral of fx, okay. So how will I represent it? Please look at here. I will write it as integral of fx. Check here, because differentiation of gx is fx, no, and inverse process is what? Please understand this. Differentiation of gx is fx. Then what? How will we reach integral? By using inverse process. So inverse of what? Inverse of differentiation is what? Integration. So I have differentiated gx, right? Please understand. I have differentiated gx. So I will integrate what? Gx only? No, sir, fx. I differentiated gx to reach fx, right? So I will integrate fx with respect to what? The variable x. That's why you read this here. Integration of fx with the variable x, okay. Then what do I get? I get gx plus c. I get gx plus c, where what is c? C is the constant of integration. C is the constant of integration. Because of this c value, see, this c is a constant, okay. This can be any number. In different situations, this c can be any number. Now, for that reason, what happens? This answer will not be unique, okay. Because if I change c value from 1 to 3 to anything, a constant value, then this value will keep, making or being a different to each other. So again, it will be not unique. So that is why indefinite, okay. If I restrict it, if I restrict the c value, how we restrict it, we'll see in the coming classes. If I restrict the c value, then it will become definite kind, okay. We'll see. Chaliye, moving on, okay. And note, antiderivative of or integrals of any function is not unique, okay. So we choose this c, as any constant value, okay, which can be changed by giving certain boundary conditions. You will see in physics, no, if you have learned physics, okay, right now if you're solving questions in physics, there are in the problems, let's say when you're dealing with thermodynamics, okay, if not right now, then higher order problems in thermodynamics, okay, whenever heat transfer is involved, or other type of questions, other categories where the boundary conditions are defined, even in mechanics also. So in different situations, okay, I will not be able to give you examples right now, but in different situations, whenever the boundary conditions are defined, I am dealing with integral problems. Those boundary conditions will help me what? To find this constant c, okay. So because of this limitation, this restriction in the domain or the boundary condition, I can identify c value, then this value will become unique in nature, okay. Right now, not unique, okay. So this is how we represent it symbol wise. Integral of fx dx means integral of function f with respect to x. This is how we read it. Fx dx means integral of, I read this earlier also, integral of function f with respect to the variable x, okay. Whereas fx is the called integral and x is the variable of integral. Okay, simple enough, simple things. Chaliye, now we'll take some formulas. Okay, we'll take some formulas on which we will solve the questions today. Okay, so beginning of the first formula, from the very first, if you remember this formula. So for some questions, for some functions, I will write differentiation first, and then we'll go to integration from there. So I'll write the differentiation over here, and then we'll relate and write integration over there. So let's see. Then we'll write simply for integration in the other set of formulas. But for now, let's check first one, the simplest one ever. Differentiation of, let's say I have kx. What is my answer? Tell me. Very simple. It's k, sir. How, sir? I take k common. X differentiation is 1, so simply k. That's why my first formula will come from here only. Integration of any constant k with respect to what variable? Dx. What I'm gonna get? Simply kx plus c. C will come, bacha. C will come. How, sir? Constant of integration will be there. Okay. Now, this formula, second one. Integration of x power n dx. What will I write this for this? It will become x power n plus 1 upon n plus 1. If you remember in the previous case, what was the differentiation? We should take this n over here. We should take this n over here. If you want, I can differentiate this. I'll show you. I'll differentiate this part. Check here. I'll differentiate this part. Differentiation of what I'm going to take? See, integration of this is this. Understand this. After adding this function over what, we'll see that, not required right now, but after adding these functions xn, okay, xn, okay, I got this as my result. It means after differentiating it, after adding, I got this. After breaking this into smaller part, I'll get this, right? Correct? So let me differentiate this. We should get this. Let's check. Differentiation of what, bacha? This part, x to the power n plus 1 upon n plus 1 is there, right or not? Plus c is also there, sir. Okay, plus c we will take. Differentiate this. What's the formula? 1 upon n plus 1 is a constant. I'll keep it outside, right? Variable is x to the power n plus 1. What is the differentiation? I take n plus 1 outside, and then x to the power n plus 1 minus 1. The formula differentiation of this, remember this. N times of x power n minus 1. So in this case, n was n plus 1, so I wrote n plus 1 here. And this has x power n plus 1 minus 1. Okay, and what about constant c? Simply 0, sir. Simply 0, sir. Yes or no? Let me erase this, not relevant for us right now. Okay, this and this cancels out. Okay, this is simply 0. What is my answer? 1 and 1 also cancel. X power n. Check here. I integrated x power n to get this result. Now if I differentiate this thing, I get the same result xn. That's why I said integration is the reverse process of the differentiation. I took integration, I got this result. I differentiated this part, I got this result. Okay, I hope you understood this part. Let me continue now. So just I explained you this thing. Next, 1, 2, third formula, integration of, okay, 1 by x, integration of 1 by x with what? Dx will be what, bacha? Ln x. Okay, what is it? Ln x, again what? Plus c. Next what? Remember this? Differentiation of this was 1 by x, right? Integration will be in the reverse manner. Okay, now if I see for e power x, okay, again with dx, always write this. If you see the differentiation, we should write what? Dx over here. Okay, for the integration, what happens? This dx goes on the numerator side, comes here, ex dx. What is the answer? Integration was also same, sir. Remember this? Differentiation of e power x was same as e power x, so is the integration also the same. Moving on, fifth one, integration of a power x, again dx. Okay, what will write this? A power x ln a. A power x ln a plus c. You agree with this part? No? Please differentiate this. Okay, I'm doing for the fifth one. Differentiate this, bacha. Differentiate a power x upon ln a plus c. If I do that, what is for differentiation of, I'll keep 1 by ln a outside. It's a constant value because a is a constant. For ax I'll get what? I'll get a power x only with ln a, and for c I'll get 0, right? Since it is 0, so nothing, I'll cancel this. What I'm getting? Please check. A power x. So if you integrate a power x, you get a power x upon ln a. If you differentiate the right hand side, you'll get simply a power x. So again, correct na? Integration inverse is differentiation, or differentiation inverse is integration. Okay, all right. Let's look at some trigonometric function also. Okay, so again, as we keep going ahead in the sessions, okay, I'll give you more and more formulas, but for now, whatever is involved in the session today, we'll deal with only those. Okay, so remember this: integration of sin x dx. Okay, this is formula number 6. What is this going to be? Remember, sir, cos x. Is it right answer? Are you sure? Incorrect, sir. Actually, not just cos x plus c. Is this right still? No, sir. Minus cos x plus c. Why, sir? Why? Remember, differentiation of sine versus cos. Remember this. So if I differentiate this part, differentiate this, differentiation of minus cos x plus c. What was this, bacha? Please check. This will be what? Minus cos x will become what? Sin x. No? What? Minus sin x, right? And this will be simply 0. How much is that? Please check. This is going to be plus sin x. Okay. So differentiation of this part is sin x. Okay. That's how we are getting it. So minus cos x. So 7th formula. I hope you can get this right also. Cos x dx will be what? Okay. How much is that? Sin x plus c. Okay. There is no sign change here. Okay. What about this one? 8th one. Integration of. Okay. Integration of sec square. Sec square x dx. What is it, bacha? Tan x. Why, sir? Differentiation of tan was what? Sec square. So integration of tan x sec square is tan x. What about this? Integration of, same way we can do for cosec square x dx also. What is that, bacha? Minus cot x. Minus cot x plus c. Okay. Now integration of sec x tan x. How much is this? With dx, obviously. This is what? Sec x plus c. Sec x plus c. Same thing I can do for integration of what? Cosec x and what I'm going to call sec x, right? Sec x with dx will be what? Minus cosec x plus c. Okay. So 1, 2, 3, 4. 2 to 4 to 6. I think that's all. Okay. If I'm missing any of the formulas, I'll come back and recall it. I think this is okay. Again, for inverse also I can write the same way. Let me write one of the inverse. Inverse. So integration of 1 upon 1 plus x square. What is this? Simply tan inverse of x. Okay. So basic idea is you know the formulas of differentiation, right? Just apply the inverse of that. You'll get the answers over here. Same you can do for other integration also. Okay. So let me just move on to the questions now. I hope you can see these formulas. Okay. Most of the time we will use this formula, and these also are very, very important. Okay. Chaliye. Now today's session is very, very basic. We'll solve only some of the questions. Okay. And then when we come with advanced questions, no, when we come with different types of integration, what are the approach to different type of problems, then we'll see all of these things again. Whatever is required in the concept while solving the question, I will give it to you. Okay, I'll explain it to you there also. Some properties of indefinite integrals. Again, what I said, no, there are two types of integrations. First one is indefinite, other is definite. What did I say? Today we'll only talk about indefinite integral. Only talk about indefinite integrals. Okay, not only today. For the coming sessions, we'll be talking about only indefinite integrals. Okay. So this is the property. Derivative of f dash of x. If you integrate with respect to x, you'll get what? Fx plus c. Correct, right? This was a statement. I took derivative of gx as fx, and same thing was given in the definition statement also. Okay. Now if I have integration over addition or subtraction, if I have to integrate over addition or subtraction of two different functions. See, function 1, function 2 are added or subtracted. If I am integrating that with respect to what? X, I can do it individually and add also. So whether you add or subtract and then integrate, can have the same result as first integrate and both of them, both the functions, and then add. First integrate and then add. Okay. If I have a constant multiplied to the function, I can take the constant outside and then integrate it. We'll have the same result. Okay. Okay, fine. Chaliye. Okay. Think about it. Differentiation of f of x dx. Differentiation of integration is same as this thing. Think about, no? First integration, then differentiation of that is equal to first integration and differentiation of that. If that is the case, it means what? The function this and this are, or this integration are equivalent functions. Think about it. It means that if I differentiate, let's call this to be a function p. I'll call this to be a function px. Think about it. Yes, integration, right? Integration will give me another function, so px, and I'll take this to be a function qx, let's say, q of x. They are saying that derivative of px, they're saying that, what is this? Derivative means, they're saying p dash of x is equal to q dash of x. When can two functions will have same derivative? When they're equivalent to each other. That's why they're saying fx dx, or this integral, which is px, is equivalent to the integral of gx dx, which is qx. Simple enough. Okay. Since the differentiation of two different functions integral are like this, it means the functions are equivalent. I've taken this function to be px, this to be qx. Okay, I hope this is simple. Okay, please let me erase this part. Okay. Okay. Chaliye. Do I have question coming up? First one, first problem based upon trigonometry. Okay, let's see how will this work. So I can expand this question. Integral of 2 tan x minus 3 cot x the whole square with dx. Okay, let's see. So I can do this integral of a minus b the whole square. No, this is my a and this is my b. How can I rewrite this? So 4 tan square x, 4 tan square x plus 9 cot square x. Yes, 3 cot x will be squared as 9 cot square x, and minus 2 times 3 will be 6 times 2 will be 12 tan x times cot x. I hope you are not thinking why. I am not thinking why, because a square plus b square minus 2ab. Okay, and we write the next step, integration of, I can write this as 4 as it is. Yeah, 4 as it is, and this tan square x as what? Please check. 1 plus tan square is what? Sec square, right? 1 plus tan square is sec square. Yes, identity. See here, 1 plus tan square theta is sec square theta, sir. So what is tan square theta? Sec square theta minus 1, sir. Yes or no? Minus 1. So let me just rewrite it in place of tan square. So sec square x minus 1. First one is done. Same way you do the cot also. 9 times of cosec square x minus 1. Okay. And what about this? Simply minus 12. Please see this. Why? Why, sir? Tan x into cot x is 1, right? Tan and cot are reciprocal to each other. So into is 1. Now I'm going to do what? Expand this bracket. Integral of this will become what? 4 sec square x minus, okay, what is this? Minus 4 plus 9 cosec square x minus 9 and minus 12. Okay, now integration of this with respect to x. Okay, please see this, integral of this will be what? So I will rewrite this, arrange minus 4 minus 9. How much is that? Minus 13 with minus 25, minus 12 will be minus 25. So I will write it as 4 sec square x, and I said that if you have sum or difference of multiple functions, you can take their integral to individual functions. So individual, I am taking 4 sec square x, but I have to write what? Dx also. Correct, na? This is there, but integrating with respect to what variable? For the variable x, so dx also. Then what is this? Integral of 9 cosec square x with what? Again dx, and minus what? 25, right? So integration of 25 dx. Okay. All right. So what will this become? Please tell me. What will this become? Now I can take things common, right? I can take things common, right? So I can take 4 here and write it as sec square x dx plus 9 here cosec square x dx and minus 25 here simply dx. Please check. Please check. I've taken 4 over here, this 9 over here, and this 25 over here. Constant can be taken common, right? Constant can be taken common, right? And taken outside of the integration. Same thing I've done here. Now if you integrate, what is the integration of sec square? 4 tan x, right? What about cosec square? Plus 9 times of minus cot x, okay? And what about this? Minus 25, what is this? I'm integrating dx, right? So it can be written as simply x, okay? Because nothing is there, only 1 I can write. If you want, I can write it as 1 times of dx. What is the integration of 1? X. Why, sir? Differentiation of x is 1, integration of 1 is x, okay? And we are doing integration, right? First, second, third. So I can simply add here a constant c. Sir, isn't the individual integration will have a constant? Should it be c1, c2, c3? We should have 3 integration because 3 integrations of 3 constants, c1, c2, c3. But we can add it to write it as 1 constant as c, because constants, right? We don't know the value anyway. Just write it as c. Don't write 3 different constants, okay? What's my final answer? This is it. 4 tan x minus 9 cot x minus 25 x plus c. This is what, bacha? My integrand. Okay, this is what they're asking. I value is this. After integration, what? This is my value. Okay. Please have a look. Please have a look. Yes. Okay. Moving on. Question number 2. Integration of 3 sin x minus 2 cos x. So same process, same exact process. Apply integration to individual terms. Okay. So if I do that, I can write this directly as 3 sin x. Okay. Dx will come because if you are integrating, if you write the variable we are integrating with respect to, so dx will come. Minus sign is there, so minus 2 integration of cos x, again dx will come. Okay. Same thing over here, plus 4 integration of sec square x, dx will come. And same thing, minus 5 integration of cosec square x, okay, dx will come. Yes or no? Yes, sir. Let's simplify this. This will be what? 3 minus cos x. This will be what? Minus 2 sin x. What will this be? Plus 4 tan x. And what will that be? Minus 5 minus cot x. Okay? Plus c. Let's just arrange this with the signs and all. It will be what? Minus 3 cos x minus 2 sin x plus 4 tan x, and this is plus 5 cot x plus c. My final answer. Yes? Okay. Simple question, very simple, similar to the previous one. Okay. All right. Now over here, we have to apply some modifications. Okay. Now, first 2 questions I took on trigonometry because trigonometry is relatively simpler in integration, because straightforward formula is there. I wrote it in the rules where we were talking about the integration formula for different functions. So I already took that. So that's why I took some questions from the integration of trigonometry. Easier for us to understand the concept of integration from there. Okay. Let's solve some questions now, where you have to apply yourself, apply your learnings. So let's see. So to solve this, please check. I have to make some modifications. You'll see how. So I can write this as, please check. I can write this as 2 plus x. I'm clubbing this together. Okay. So 2 plus x upon x square 2 plus x. Yes. Yes. And I'm writing this as plus x square upon 2 plus x times of x square. Okay. And what about this? I can write this as 2x upon x plus 1 the whole square minus 1 upon x plus 1 the whole square, whole thing integration with what? Dx. With what? Dx. Okay. All right, chaliye, let's see. Okay, now check here. Cancel. Okay, we can't cancel this part. So what is the new integration that we have? Integration of what? 1 upon x square with dx. What is over here? Plus integration of 1 upon 2 plus x with dx. What is here? Plus integration of 2x upon x plus 1 the whole square with dx. And what over here? Integration of, what is it? Dx upon x plus 1 the whole square. Am I right? Yes. Okay, let's see. So over here, if you check, what is this? 1 upon x square. Okay, it means simply 1 upon x square means x power 2, x power what? I can write it as minus 2. Okay, I can write this as x power minus 2 dx. Okay, what about this? Integration of, okay, this is very simple. Okay, log of what? 2 plus x. Correct or not? Yes, right? What is the differentiation of this? Tell me. Differentiation of this will be log of 2 plus x will be what? 1 upon 2 plus x times 1. So same thing is written here. Yes. What about this? What about this? Okay, please check here. If you differentiate this with the log, if you differentiate with the log, it will be what? This will come in the denominator. This will come in the denominator, and this is what you're going to do? Differentiate 2 into x plus 1 also. Yes. Okay. So now this question, integration of, okay, now what we have done so far is, why I took the first two questions to be trigonometric function, because they are very simple. Okay, directly we know the formulas for integration. I just showed you on the previous slides. So we know the formulas of integration of trigonometric function. We can get to the answer directly. But over here in this question you have to apply yourself. Means how can you make changes in the function which is given so that it can be integrated easily. Okay, that's why a very good question. Okay, we'll see how we can transform this function which is given in the bracket so that we will be able to reach our answer. Okay, chaliye, let's see. So I can see one thing is 2 plus x is common here. 2 plus x is common here. It means if I break this, and x square is also common. If I break this like this, I'll write this integration again in this form. 2 plus x upon x square plus 2 plus x. Okay, not plus, sir, not plus. Let me rewrite it. 1 second. So integration of 2 plus x upon x square times of 2 plus x. Okay, and plus what? X square times of x square 2 plus x. Okay, this is over whole thing. Next what? I have to rearrange this part. So over here I can get rid of few things. So we'll see that later in the next step. Over here, how can I get x plus 1? How can I get x plus 1? So for me to get x plus 1, there has to be what? A common 2, because 2x is there. So let me write this here. 2 times of x plus 1. How much is that? Please see how much is that. It's going to be 2x plus 2. But we have only 2x minus 1. Okay, means I have added something. What? I have added something. Check here. So I have to do what? Minus 3. Please check. How? So think about it. I simplify this. 2 times of x is what? 2x. 2 times of 1 is what? Plus 2, and there is a minus 3. 2 minus 3 is how much? Minus 1. So 2x minus 1 I can rewrite it as 2 times of x plus 1 minus 3. Okay, I hope this is simple. I hope you understood this part. Okay, I hope this was not fast. चलिए आगे बढ़ते हैं. This we write it as x plus 1 the whole square. That's why I said we have to do certain modification to the function to make it easy to integrate. Okay, let's see. So over here you can see 2 plus x will cancel with this 2 plus x. X square will be cancelled with this x square. Okay, now I'll write this again. So I can write it as simply 1 upon x square plus 1 upon 2 plus x. Okay, plus what will this be? 2 times of x plus 1 upon x plus 1 the whole square minus 3 upon x plus 1 the whole square. Okay, dx. Okay, see this getting cancelled, Now I can write this integration of individual functions also. So integration of what? 1 upon x square with what? With dx. Same way I can write here plus integration of 1 upon 2 plus x with what? Dx. Yes, and same way I can write it over here, integration of 2 upon x plus 1. Why x plus 1, sir? Because the square is cancelled, bacha. Okay, with what? Again dx will be written minus 3 upon integration of x plus 1 the whole square with what? Again dx. Okay, because ds is there for all the functions, right? We have to integrate entire function with respect to x only. So let me see on the next step. I can read, this is my steps, right? These are my steps. Okay, if I rewrite this statement, I can write it as, please check, integration of x to the power minus 2 dx. Yes or no? X power 2 is in the denominator. I can write it as x power 2 in the numerator with the minus sign. Yes. Next what? Please check. Integration of 1 upon 2 plus x. Okay. So this is simply what? Log of, if you integrate this, it will simply be what? Log of 2 plus x. So ln 2 plus x, 2 plus x. Please check here. Okay. Now over here. Now if you integrate this, you'll get what? 2 times of ln x plus 1, because 2 is a constant, I can keep it outside. 2 times of ln of x plus 1. So plus 2 times of ln x plus 1. Okay. Okay. All right. 2 plus x and x plus 1. And what about last one? I can rewrite this as minus 3 integration of x plus 1 the whole square. But what type of whole square? Okay. Its denominator is there, right? So I have to write it as power minus 2. Power minus 2 integration with dx. Okay. Okay. Let's see here. So if I integrate this, what am I going to get, bacha? I'll get it as x power minus 2 plus 1. Integration is done, right? So plus 1 upon minus 2 plus 1. This is done. This is, so we already did this, ln of 2 plus x, right? What is this? 2 times of ln of x plus 1. What about this? Minus 3 times of x plus 1 power minus 2 plus 1 upon minus 2 plus 1, right? And the constant c will always come for the integration. Okay. Now please check here. What will this become? This will be what? So 1 upon, please check here, my final answer. Again my steps, my final answer. Minus 3, what is this? Minus 2 plus 1, how much is that? Minus 1. So I can simply write here minus sign. And what will this be? X power minus 1. It means x power minus 2 plus 1 is plus 1. Okay, minus 1, right? So minus 1 means denominator I'll get x power minus 1 will be 1 by x. Over here simply ln of 2 plus x plus 2 times of ln of x plus 1. And what will this be? Please check here. Minus 3 times of, this will become what? This will be minus 1 only. So will become plus minus 1 from here. We'll make this positive. So plus 3. And this will be what? Upon x plus 1. Why, sir? X power x plus 1 power minus 2 plus 1. So minus 1 means reciprocal. So x plus 1 plus c. This is my final answer. So see, after modification, easy to integrate. I hope this is visible. Please have a look. Yes. Okay. Moving on. Question number 4. This is not that difficult. We'll see how. Check here. I have this integration given as integration of x plus 1 divided by root x basically. X power 1 by 2 means root x only. Okay, simple, very simple. Take in 2 different parts. So x upon root x dx. I'm separating the integration plus integration of 1 upon root x dx. Please check here. If I integrate this, what I'm going to get? If I simplify this, I'll get what? Root x dx. Okay, root x dx. And what I'll get here? If you see here, I'll get it as okay, 1 second. Okay, I'll get it as x to the power minus 1 by 2 dx. Okay, correct? No, because root means what? 1 by 2 only. No, same thing I've written here, 1 by 2. So I can write this integration of what? 1 by 2. So I'll rewrite this as integration of x power 1 by 2 dx plus integration of x to the power minus 1 by 2 dx. Please integrate both of them. What we're going to do? Same thing, sir. the formula of the polynomial x power n plus 1. So x to the power what? 1 by 2 plus 1 divided by same thing. Same thing we'll do over here. X power what? Minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c. My steps. These are my steps only. What I'll get? X power 3 by 2 upon 3 by 2. What I'll get over here? Please check. X power 1 by 2. Okay, positive I'll get. And upon what I'm getting? 1 by 2 again plus c. Okay. So what is my final answer? 2 by 3. Please check here. 2 by 3 because 3 by 2 is in denominator, right? We'll go up and become 2 by 3. X power 3 root 2 means what? X root x. It means x root x. 1 by 2 plus 1, right? So 1 means x and 1 by 2 means root x. And over here simply it will be 2 root x plus c. My final answer. What's the final answer? 2 by 3 root x plus 2 root x plus c. Anything like this? They've written in the form of the same thing. So please check here. X power, this thing will be there. 2 by 3, all positive. Okay. Okay, is it negative? Is it negative? Is it negative, sir? Okay. This should be positive actually. Not negative. Please check. It's positive. It should be positive, okay? 2x. So now if you check, cross check your answer. 2 by 3, x power 3 by 2, and then x power 1 by 2 with 2, right? And then with c. So option number C is my correct answer. Please make this change. This is positive, okay? C, okay? All right. If you want with the same answer, I can write like this: 2 by 3, x to the power 3 by 2 plus 2 with x power 1 by 2 plus c. Same thing is there. Please check. Okay. So root I can write it as power 1 by 2. No, so 1 plus 1 by 2 is 3 by 2. Simply 1 by 2. Let's move on. I hope this is simple. Yes. Okay. Now what? This thing you see. Integration of e power x log a e power x dx. Okay. See, exponential function with log is there, but then another exponential function is there, e power x. How will you simplify this? Please see. So if I take this x, because we know that if I have log written like this, log of a base with the log of a with what? X in the coefficient, I can write this as log of a to the power x, right? Na? Log function. Now if I apply, we also know that if we have e here and if I apply e over here, okay, then e and log e are inverse function. E and logarithms are inverse function, means what is the answer? Simply a power x. It means that this part, you see this part over here, please check. This part over here will make what? A power x. What is it? A power x. So I can write this again as integration of a power x, e power x. Okay. A is a constant with the same power. I can rewrite this as integration of a power x dx. What's the integration of the exponential function? Very simple, sir. Will remain as it is with what? ln of a in denominator, or log of a in the denominator. Option number this. I write it as log or ln, same thing. Plus c will come. Option number B is there. Option number B is the answer, bachcha. Option number B is the correct answer. Moving on. Okay. चलिए आगे बढ़ते हैं. Again, antiderivative means what? Integrals only. It means integral only of this 2 power x plus 3 power x upon 5 power x. How can I integrate this? So again, over now it looks what? Right now it looks difficult. We'll modify it again. Write it as integration of all this become 2 power x, 5 power x plus 3 power x and 5 power x. Okay, two different integration with what? With respect to dx only, both the places, dx only. Okay, with both dx only, not visible, both with dx only. Okay, let me rewrite it. So I can write it as integration of 2 by 5 with the power x dx plus 3 by 5 with the power again what? X dx. This can be a constant, right? 2 by 5 can be a constant. It is a constant, 2 by 5. What's the formula for this? Same thing will be there in the numerator, divided by log of this thing. Remember this a power x integration is a power x by log of a. Same thing will be here. 3 by 5 with what? Power x upon log of 3 by 5 and plus c. Check any option like this. Check any option is like this. Option C, okay, constant is missing, so plus C. 2 by 5 x log of 2 by 5, 3 by x, 3 by 5 of x log of 3 by 5 plus C. Option number C. Question number 6 is also done. Okay, question number 6 is also done. Very, very simple. Looks difficult over here, but once you take it in this form, simple, sir. Okay, moving on. Now saying that differentiation of a function is given as this. Find the differentiation of the function when x is changed to x cube. Okay, कर लेते हैं. Let's do it. So let's see here. Differentiation of fx is what? They're saying 1 upon 1 plus x square. Are you able to relate this? Are you able to relate to this? If I take the dx on that side, I'll get what? D of fx, okay, equals to 1 plus x square and d of x. Integrate this now. Integrate this. I'll get what on this side? D of fx means very small x, okay? If I integrate all the small fx, you'll get what? You'll get fx only. Think about it. If the function is, let's say, defined like this. This is my function fx. Let's say this is my function fx. Okay, what is the meaning of d of fx? It means this small part, sir, this small part. Okay, this means that any small part like this will mean what? D of the function fx. Okay, now if you integrate all these small parts, what are you gonna get? You're gonna get the function fx, right? Integrate all the small parts of fx, you'll get what? Function fx. Okay, function fx. Okay, this will be equal to what? Integration of this is what is this, sir? This is tan inverse, bacha, tan inverse of x plus c. Correct, na? This is what? Inverse of tan inverse x differentiation is this. So integration of this will be tan inverse of x. C will come for the integration. Okay. Now I got my function defined. So now they are saying what? Differentiate this with respect to when x is x cube. Let's see here. So I'll write this now. When I have function fx given as tan inverse of x plus c, then if I'm writing this function f of x cube, this will become what? Tan inverse of x cube plus c. Wherever is x, I'll replace it by x cube. They're asking us to do what? Differentiate this f of x cube. They are asking us to differentiate. Please check. Differentiate this. What I'm going to get? Differentiate this. 1 upon tan inverse in differentiation is 1 will be as it is. I'll write it as x cube, whatever is there. Square of that. Then what? Chain rule. I have to differentiate x cube also. So 3x square. What is my answer? Please check. For c will be 0. For the constant c will be 0. What is my answer? 3x square upon 1 plus x power 6. Yes or no? 1 plus x cube square is x power 6. Any option like this? 3x square upon 1 plus x power 6. X power 6. Option B. Simple enough. Simple enough. Yes, sir. Okay. Moving on. Question number 8. Question number 8. Integration of 2 power x plus 1 minus 5 power x minus 1 upon 10 power x. Right now looks difficult to integrate. Okay, what we're going to do? Simplify it so that it's in the form of integration. Okay. So I can separate this 2x plus 1 upon 10 power x, and this as with again with dx, and this as integration of 5 power x minus 1. Excuse me. I'll write what? 10 power x here. I'll write what? 10 power x dx, bacha. Correct? Correct, right? Now if you do this, what are you going to get? Please check. I can write 10 as what? 2 into 5. Let me write that. 10 as 2 into 5. So this will be what? 2 power x plus 1 will be 2 power x into 2 power into 2. 2 power x plus 1 will be what? 2 power x into 2. And same way I can write this as 2 power x times of, not 2, 5 power x, right? Please see this. 2 power x plus 1 means this is x, okay? This is x. Looks like n, but it is x only. Okay? So 2 power x plus 1 means what? 2 power x times 2, correct, right? If the power is 1, I can add them. Same way here. 10 is nothing but 2 into 5. The whole power is x. It means 2 power x into 5 power x. Okay? Same way, I can go over here also. 5 power x minus 5 means what? 5 power x minus 1 means what? 5 power x upon 5. 5 power x upon 5. And what about this? 2 power x times of 5 power x dx or not? Dx or not? Yes. check. Okay, this is also dx. Okay, now integrate this. What is this going to be? Integration of, I have a constant 2, I'll take 2 outside. What is this? 5 power minus x dx, right? How, sir? Please check how. I have everything cancelled. 2 is a constant, 2 is outside. 5 power x in denominator becomes 5 power minus x dx. Negative sign here. What is the constant here? 1 by 5. So I'll take 1 by 5 here. What is this? Only 2 power x is left in denominator. 2 power minus x dx. 2 power x is left in denominator. So 2 power minus x. Integrate this. What is this formula? A power x, a power x. Okay. So 2 times of 5 power minus x upon what? ln of 5 with the minus sign. Correct? Because there is a minus here, no? So minus sign. Same thing will go here. So minus 1 by 5. What? 2 power minus x upon ln 2. Minus ln 2. Okay? Plus sign, plus c will come. Plus c will come. Now if you see here, simplified answer, I'll get what? What is my final answer? Please check. My final answer would be minus 2 by ln 5 power minus x, 5 power minus x. This will be this minus and this minus will become plus, this minus here, this will become plus, so minus and minus will become plus. So I'll get what? 1 by 5 ln 2 plus 1 by 5 ln 2 2 power minus x plus c. This is my answer. Please check. Plus 2 power minus x plus c. Same thing I've written here. Okay. So I hope this is visible to you. Okay. Moving on. Okay. 1 plus 2 sin x upon cos square x. Okay. Trigonometric. So these are the very, very simple. Let's do it. What I'm going to get? 1 upon cos square x plus 2 sin x by cos square x. Simple enough. Dx in both the terms. So write it here. Okay. Write it here. I'll get what? 1 by cos is secant square x. Right with dx. Plus sign is there, so plus sign. Integration again. What is this? 2 sin x by cos square x. This is not alpha. Okay. 2 sin x by cos x will be, I can write 2 here. Sin x by cos will be what? Tan. And one more cos is left in the denominator. There are 2 cos, right? Sin this cos will make tan. One more cos is there. It will become what? Secant x. Again with dx. What's the integration over here? Please check. This will be what? Simply tan x. This will be what? 2 secant x plus c. Any option like this? Tan x plus 2 secant x plus c. Option C. Simple question. Very, very simple problem. Okay. Sin 2x minus 4 e power x. Okay. Again, very, very simple. No problem here. We can do it here only. So separate the integration for both the terms. Right? First trigonometric, then exponential. Okay. Check here. Sin 2x dx. Then what will write? Minus 4 e power 3x dx. Okay. Simple, right? How will I do this? Sin 2x will become what? Minus cos 2x, right? Minus cos 2x, right? And I'll divide by 2. Why, sir? Because there's a 2 here. So I have to divide by that constant 2. Okay. Now plus. No, this will be minus only. 4 upon e power 3x. Integration is what? E power 3x only. But divide by 3. Divide by 3. Okay. Plus c. Please check answer. Minus 1 by 2 cos 2x minus 4 by 3 e power 3x plus c. Any option like this? Is it option number 3? Option number 3 or C. Okay. If you're not clear, I'll show you the differentiation. If you want, I can show you the differentiation. Differentiate this over here. Minus 1 by 2 will be as it is. Differentiation of cos 2x. Differentiation of cos 2x. What is that? Minus sin 2x. Yes or no? I have to do for 2x also. So into 2. Same way I'll do for this. Minus 4 by 3 will remain as it is. E power 3x will be e power 3x times of 3. Because for 3x will be 3. 3 and 3 will be cancelled. This 2 will cancel this one. Plus and plus. What is the left? Sin 2x minus 4 e power 3x. So this is the integration. This is the differentiation. Reaching back the same thing. Okay. Again, this is, I'm writing it over here, but not relevant. If you are thinking why I divided by 2, whatever is the constant here, I have to divide by that number, okay, in both the cases, in all the functions, okay. That's why I divided by 2 and 3 here, okay. Chaliye. If somebody has this doubt, I hope this is clear now. I have taken this function and differentiated it with what? X. I got the same answer as the question. Same answer as the question. Moving on. Okay. Okay. All right. Okay. Fine, sir. Very simple. Okay. Now problem number 11th. E power x log a. Same thing I did right now. If you remember, I can take x over here. It will become what? A power x. Same way I can do it over here. A over here will become x power a. And same thing I can do over here, it will become what? A power a, right? So if I transform this, what I'm going to get? Please check. Integration of e power log of a to the power x dx plus, for the second term, integration of e power log of x to the power a. Please understand this, x to the power a. And again, last one, e to the power log of a to the power a, with what? All of this with dx only, okay, with dx only, okay. Now if I integrate this, what I'm going to get? E and log will cancel the effect, inverse function. So I'll get what? Integration of e power x left, a power x with what? Same way, x power a with what? Same way, a power a with what? Dx. Please check the solution. A power x integration, a power x upon ln a, correct? What about this exponential form? So x power a plus 1 upon a plus 1, right? Polynomial form, x power a plus 1 upon a plus 1. What is this? It's a constant, sir. I can take the constant outside. And what is this left? Only dx. What is the integration of dx? Simply x. Okay, then the constant c. Okay, integration of dx is what? Simply x. So plus c. What is it? A power x ln a. Any option like this? Please check. A power x log a or ln a. Okay, then option number a only is correct. Okay, option number a. Please check. A power x ln a or log a, x power a plus 1 and a power a plus 1, a power a x. A power a x plus c. Option number 1 is correct. Simple problem. Okay. Okay, this is all simple. This is very, very simple, right? Second square integration is what? Tan. Integration of sec square is what? Check here. What is this? Simply tan. Tan of what? Same value. And with what? Divide with what is multiplied to? Multiplied to x. So minus 4. What is the answer? Minus 1 by 4 tan of 7 minus 4x. Okay. If anyone is confused even a little bit, differentiate this part. Differentiate this. What is the differentiation of tan? So first of all, let's write the constant. So minus 1 by 4 is like this, the constant. Differentiation of tan, how much is that? Sec square of 7 minus 4x. Okay, I have to use the chain rule again. So what I'm going to get? 7 for 7 it is 0. For this will be what? Minus 4. I'm doing the differentiation here. Okay, check here. Minus and minus is plus, 4 and 4 is cancelled. What I'm getting? Sec square 7 minus 4x. Same thing. If you're not satisfied with this answer, okay, if you're not able to relate with it, sec square integration is simply tan 7 minus 4x. What is there? 4 is multiplied to x. Whatever is multiplied to x, you divide by that. Same thing we did over here also. Please check. Multiplied to x, 2 was multiplied, so divide by 2. Multiplied to x, 3 was multiplied, so divide by 3. Okay. This problem also the same thing. Multiplied by minus 4, so divide by minus 4. This is my answer. This is just to verify. Differentiation I have taken just to verify. Not part of the answer. Not part of the answer. Just to verify this. Okay. Not part of solution, sir. Okay. I hope this is simple. Okay. So we have completed the session today. First one, I told you nothing much we'll do only questions on indefinite integral, very, very basics one, because I wanted to have a session where we have used all the formulas that we learnt for the integration, and we'll use and solve all the questions or based on these formulas. So we'll get used to the session, get used to the chapter integration. Okay, now coming up we'll have different types of integration. You'll have also methods of integration. So all of this will come in the coming sessions, so be prepared for it. Okay, if you want to if you are struggling in a chapter, let's say if you are struggling in integration, go back before the session comes, solve some questions from NCERT, then you come back and see these questions for your KCET. Okay, so I hope this was helpful. Okay, so this is it for the today's session. Keep working hard, bacha. Keep positivity around you. Okay, and be always happy whenever you can. If there might be some challenges, you might be struggling while solving the questions, it's okay. It's not about getting it right, it's about trying your best. If you're trying your best, you'll get it right eventually. Okay, so just make sure that you're changing yourself, you're working hard to make improvement yourself. That's all that matters. Okay, with that note, I'd like to conclude the session. Please take care of yourself. Bye bye.